Hello everyone. So we have discussed already the part A of stats exam which was being conducted in 2023. So we are left with part B. So in part B you are supposed to attempt any two questions from question 5, 6, 7. Question 5 consists of 5, 10, then 10. Okay, so all these questions would consist of 25 marks only. So you are supposed to attempt only two. So 50 from part B and 40 from part A. So we have already solved for part A. So in this video, if time permits, I'll solve all these questions, or else I'll solve 5 and 6 only. Okay. Fifth question, A part. Suppose the useful lifetime in years of a personal computer is exponentially distributed with parameters lambda equals to 0.25. So what is the information that we have? Lambda equals to 0.25 and x follows exponential with the parameter lambda. A student entering a 4-year undergraduate program inherits a 2-year-old PC from his sister who has just graduated. Find the probability the useful lifetime of the PC the student inherited will last at least until the student graduates. So the PC is 2 years old, but now they want to say that this PC has been given from the sister to his brother. And what is the probability that it would last 4 more years, right? So the PDF would be f of x lambda is equals to 0.25 lambda e to the power minus lambda x. So this would be 0.25 e to the power minus 0.25 x, where when x is greater than equal to 0 and 0 otherwise. So x denotes the number of years the personal computer would be in use, and this is the memoryless property in the case of exponential distribution. So they are not concerned about whether the past 2 years the PC has been already been in use or not. They are just concerned whether for the next 4 years will the PC be in use or not. Okay. So now, so we have f of x lambda equals to 0.25 e to the power minus 0.25 x. Now if we want to find the CDF for this, so we want to know that whether it would last x would be greater than equal to 4 or not. So we need to find the probability that x is greater than equal to 4. So this is nothing but 1 minus the cumulative till 4. Okay, so if we will differentiate this or integrate this, we'll get the CDF. So f of x of lambda, this is equals to 0 to x f t lambda dt. This is 0 to x 0.25 e to the power minus 0.25 t into dt. This is e. So the integration of this would be 0.25 e to the power minus 0.25 t upon minus 0.25 0 to x. So this cancels out. We are left with minus e to the power minus 0.25 t. The limits are 0 to x. So this would be minus e minus 0.25 x minus of, now you are supposed to put t equals to 0, minus of minus e minus 0.25 into 0. So this whole term, so this minus already, minus would become plus, and e to the power 0 would become 1. So we are left with 1 minus e to the power minus 0.25 x. So this is the cumulative f of x of lambda. So this is the cumulative distribution. Now we are supposed to find this. Okay, so we have found this, so this would be 1 minus f of 4 0.25, where x is 4. So this would become 1 minus e to the power minus 0.25 into 4. So 1 minus 1 plus e to the power minus 1. So this cancels out. So we are left with 1 by e. So the probability that the PC would be able to be used for 4 more years is 1 by e. Okay, now moving on to the next part of the question. Okay, just erase this so that we get enough space. Okay, so we have this question with us. Now, in this question, so in a shipment of 10,000 of a certain type of electronic component, 300 are defective. Suppose that 50 components are selected at random for inspection and let X denote the number of defective components found. So what we have is N, the capital N is 10,000. That is, there are total 10,000 shipment of 10,000 electronic components. And you are choosing a sample of 50 only, whereas the defective are 300. So not defective would be 9,700, 1000 minus the defective. So total there are 10,000 and you are choosing 50. Now you are supposed to find the probability that x is less than equal to 3, where x denote the number of defective components. So out of the 50 you have chosen, they are asking that the probability, you need to find the probability that the defective are either 0 or 1 or 2 or 3. Now this is a case of hypergeometric distribution. Hypergeometric distribution. Now the probability that x is less than equal to 3 will be given by probability x less than equals to 3 is probability x equals to 0 plus probability x equals to 1 plus probability x equals to 2 plus probability x equals to 3. So this would be given by, so if we are choosing 300, 300 are defective, and out of 300 defective we are getting 0 as defective. So it would be 300 C naught, and 9,700 were not defective. So we'll get all the 50 from this only. So basically we were choosing 50 from a total of 10,000, out of which 9,700 were not defective, 300 were defective. So this shows out of 300 we are getting no one defective, and out of 9,700 we are getting 50 as we are able to get 50. So basically this shows that there are no defective pieces. And the other case, when there is only one defective piece, so this would be 300 C1, and from the rest of it we are getting 49. Then similarly 300 C2 and 9,700 C48. Then 300 C3, 9,700 C47. So these are the total combinations, and then divided by the total options available, 10,000 C50. So this is the probability. You are not supposed to find this. You just need to write this in your answer. Okay. Now moving on to the next part. Okay, now moving on to the next part, we have find expected x and variance x. So you should know the formula for this. For the hypergeometric distribution, you should know the variance x and expected value of x, and for other distributions as well. Binomial, Bernoulli, normal distribution, you should know these formulas by heart. So expected x is n into m by capital N. So small n was 50. Okay, so we were small n was m by capital N. Small n was 50. Capital M, that is the defective items, were 300 and capital N was 10,000. 2. Okay, I'm not sure whether I have written the formula right or not. So small n was 50. 50 into 300 upon 10,000. So 50 into 300 upon 10,000. This cancels out. This cancels out. So this is 2. So 3 by 2. So on an average, you will have 1.5 defective items with you. Okay. Now coming to variance x. The formula for variance of x is n minus small n. So you should know this. Just remember this. Okay, I'll write it here. For the variance, the formula is variance of a distribution which follows hypergeometric, okay, is given by capital N minus small n, the small sample size, n minus 1 into small n times m upon n, 1 minus m by n. I know this is a bit lengthy to remember, but you are supposed to remember this. So this is 10,000 minus 50 upon 10,000 minus 1, which is 9999, multiplied by small n is 50, capital M is 300, then 10,000, 1 minus m was 300, then 10,000. So this is coming out to be 10,000 minus 50 divided by 9999. This is coming out to be 0.9950. 0.9950 into, so to 1.5 into 300. 1 minus 300 divided by 10,000 is 0.97. So 1.5 into 0.97 into 0.995. So this is coming out to be 1.447725. Okay, still 4477 is fine. So we have found the variance as well. Now coming to the third part. You are find an approximation to the probability p x less than equal to 3 and compare it with the exact probability found in part 1. Since the programmable calculator is not allowed, you won't be able to find this exact probability that we have already discussed. Which distribution would you use to find approximate probability? Give reasons for your answer. Okay, now, so if you have gone through the propositions and the theorem, you would know the approximate probability distribution would be binomial distribution. Binomial distribution. Provided the sampling, when we're talking about choosing these 50 people, 50 components, this is done without replacement. So we'll get the binomial distribution. And the second condition is small n by capital N is at most. So this value should be less than 0.05. Then And these two things, if these two things are being taken care of, then it would follow a binomial distribution. Now, small n by capital N is 50 upon 10,000. So 1 upon 200. Just to be double sure, you can use the calculator. This is giving you 0.0, is giving you the value 0.005, which is less than 0.05. So if it is without replacement and this is satisfied, it will follow a binomial distribution. We have P. For the binomial distribution, we have n, the number of elements, P and Q. So the chances of a defective piece is 300 upon the total 10,000. So this is 0.03. So the chance of a non-defective piece would be 0.97. Okay. So the distribution is binomial with npq, small npq. N was 50 into 0.03 into 0.97. So binomial distribution. And now we are supposed to find probability x less than equals to 3 with the help of binomial. So this would be the cumulative distribution CDF of binomial with x equals to 3, and then n is 50, p is 0.03, q is 0.97. So you will get this value. Okay, so we are done with this as well. Now moving to the next part. So we have part C as well with us. Okay, now moving to part C, what we have is a candy company distributes boxes of chocolate with a mixture of creams, toffees, and cordials. Okay, so suppose that the weight of each box is 1 kilo, but the individual weights of the cream, toffees, and cordials vary from box to box. तो basically 3 components से बना है, इन तीनों का sum मिला के 1 kg है, and this keeps on varying, वो fixed proportion नहीं है. For a randomly selected box, let x and y represent weights of the cream, x represent weights of cream, and y represent weights of toffees. And toffees, and respectively. And suppose that the joint density function of these variables is, so the joint density function is given to us. This is f of xy equals to 2 by 5 2x plus 3y for x. This is this thing when x lies between 0 to 1 and y lies between 0 to 1, and x plus y should also lie between 0 to 1 because cordials would also be present, right? Now look at the first part that we are supposed to solve. Find the probability that in a given box cordials account for more than half of the weight. So if cordials are more than half, then 1 minus half. So 1 minus more than something half would be less than equal to half. So the remaining weight of creams and toffees would be less than equal to half. So we are supposed to find the probability that x plus y is less than equals to half. I'll find some. Okay, I'll do it here. Now, so given the function, you must be aware of the double integration by now. 0, 0.5 and then 0 to 0.5 minus x. Okay, I'll write it here. 0, 0.5, 0, 0.5 minus x into 2 by 5 2x plus 3y into dy into dx. So first we will integrate it with respect to y. So we have 0.5, just expanding this, this would be 4 by 5x plus 6 by 5 y into dy into dx. So this would be 0 to 0.5. Integrating this with respect to y, this would become 4 by 5 xy plus 6 by 5 y square by 2. And the limits would be 0 to 0.5 minus x and then dx. Now this cancels out. So we can take, okay, so we are left with 0 to 0.5, 4 by 5 x into 0.5 minus x plus 3 by 5 into y square. So this would be 0.5 minus x whole square and this whole dx. Because when you will put 0 here, this would become 0. You will put 0 here, this would become 0. So minus of 0 and 0, this will give you the same thing. So now solving this, so we'll take 1 by 5 common. We have the integral 0 to 0.5, 4x into 0.25 would give you 2x, and then minus 4x square plus 3 times 0.25 plus x square minus x. Okay, so I'll not sure. Okay, I'll write it here. I hope you are writing it alongside. So this would become 1 by 5, 0 to 0.5, two x minus 4x square plus 0.75 plus 3x square minus 3x. So now we will simplify it further. So this becomes 1 by 5, 0 to 0.5, 2x minus 3x is minus x minus 4x square plus 3x square minus x square plus 0.75 into dx. So into dx was there, into dx was still there. Now we need to integrate this with respect to x only. So we will get, writing it here, 1 by 5, 0 to 0.5. Okay, since we are already integrating it, we'll put the limits at the end. Minus x would become minus x square by 2. Minus x square would become minus x cube by 3. 0.75 would become 0.75x. So we are left with, now you just need to put the limit. Put these values and okay, so then you'll get this value. Now solving this, what we have is, okay, so this is 1 by 5, 0.5 square divided by 2 is minus 0.125 minus 0.5 cube divided by 3 minus 0.04167 plus 0.75 into 0.5, this is 0.375. So minus 0.125 minus 0.04167 plus 0.375. This is coming out to be 1 by 5 into 0.20833. So divided by 5, this will give you a value of 0.04166. Okay, so this is the value that, So this is a value that in a given cordial, find the value that in cordial accounts for more than 2. Okay, so this is the value that the cordials account for more than half of the 2 weight, which is 0.04166. Okay, this was a very long question. So, okay, we'll do the next part as well. What is the probability? Okay. I'll try to solve it here only. Now they are asking, free up some space. Okay, now they are asking, what is the probability that the weight of the toffees in a box is less than 1/8 of a kilogram? Toffees was denoted by y. So we need to find probability y less than 1/8. If it is known that cream constitutes 3/4 of the weight, so cream was denoted by x, given x is 3/4. So now we are supposed to find this. So probability of this. So we know f of y given x would be f by x upon f of. So this is the probability mass function of x. Right? And how do we find probability mass function of x? So in this case, what we'll do is, okay, so before that, okay, I'll tell you how we are supposed to find the probability mass function of x. So we know the joint probability mass function is 2/5, 2x plus 3y. Now the marginal PDF of x, marginal PDF of x would be when we will integrate this thing with respect, when we will integrate the joint mass function with respect to y, then we'll get the marginal PDF of x. So f of x becomes, the range is 0 to 1, 2/5, 2x plus 3y into dy. So this becomes 2/5, we can take common, then integrating it, 2xy plus 3y square by 2. The range is 0 to 1. Now this would become 2/5 and then 2x plus, when y takes value 1, 3/2. So this can be written as, take 2 common, 4, and this cancels out. So this can be written as 4x plus 3 upon 5. So this is f of x. Okay, and this is when x lies between in the interval, so x cannot be greater than 1 kg. Okay, now we have solved this. Now basically we are supposed to find probability y less than 1/8 given x equals to 3/4. So this would become, and okay, before that, this thing. So f of y of x is 2/5, 2x plus 3y, and fx, the sorry, the marginal distribution of x is 4x plus 3/5. 4x plus 3 upon 5. So 5 cancels out. So we are left with 2 times 2x plus 3y upon 4x plus 3. So this is f y given x. Now we are supposed to find, okay, I'll do here only. Just erase this because this would be in the continuation of it only. Okay, now this is f of y given x. Now probability y less than 1/8 given x equals to 3 by 4 would be 0 to, this would be 0 to 1 by 8 f of y given x into dy. So the same function 2 upon 4x plus 3 would be common. Now we are integrating it with respect to y. 2x plus 3y into dy. So this becomes 2 upon 4x plus 3. The limits are 0 to 1 by 8. 2xy plus 3y square by 2. 0 to 1 by 8. Now in this case it is given to us that x takes value 3 by 4. So this would be 2 times 4 into 3 divided by 4 is 3. So this would become 3 plus 3 6. 2 times x is 3 by 4 into y. So y, okay, let me write y as y only. Y square by 2. 0 to 1 by 8. 1 by 3. So we have 1 by 3. This also cancels out. 3 by 2. This becomes 2 into 3 by 4. So this becomes 3 by 2 into 3 by 2 y plus 3 by 2 y square. So we can take 3 by 2 common as well. So this would become 1 by 3 into 3 by 2. Limits are also there. Y plus y square 0 to 1 by 8. This cancels out. So we're left with half 1 by 8 plus 1 by 8 square. So 1 divided by 8 equals to plus 1 divided by 64 divided by 2. So this is coming out to be, we'll solve it, 0.0703125. Okay, till 0.073. Till 4 decimals is fine. Okay, so we have done this. So this was for 5 marks. Okay, this was for 5 marks. Now we'll do the last part. I'm just clearing some space for it. Okay, now they have given us, are x and y independent? Explain using appropriate statistical measures. So we have already found f of y given x. This was coming out to be 2 times 4x plus 3 into 2x plus 3y. And f of y, this we will find by integrating the function, the joint PDF, the joint PDF 2 by 5 2x plus 3y with respect to dx. So we will have, so this would become 2 by 5 will take common, then integral of 2x plus 3y with respect to dx 0 to 1. Okay, so this would become 2 by 5 2x square by 2 plus 3yx 0 to 1. Right, now this 2 would cancel out, so we are left with 2 by 5, and the limits will use the limits. So x would take value 1, so this would be 1 plus 3y minus 0 plus 0. So same thing only, this would remain 0 only. So we are left with 2 by 5 1 plus 3y. So this would be 2 plus 6y upon 5. So this is the probability mass function of, marginal probability mass function of y. 2 plus 6y upon 5. Now f this is f of y. If y given x, now suppose if x and y are independent, then we would have f y, so probability, so f of y, I'll write it again, f of y if they are independent into f of x, so upon f of x should be equals to f of y, or this will cancel out. But in this case, f of y of x by given x is not equals to f of y, so they are not independent. Okay, so I'll move to the next question. Okay, so question 6 also looks a bit lengthy. So what I'll do is I'll make 2 more videos for question 6 and question 7 separately. So okay, so I'll make one video for this and then the other video for question 7. Okay, these are lengthy questions only. Okay, so I'll upload this in the next video. Thank you.